Hello and welcome to another soldering session. How about that? How about that? Bet you didn't expect that shit to happen. So today I decided to start sort of like a new series. You see, I've been developing and streaming for quite some time. I think I've been doing that since 2015, and I started to stream seriously on Twitch since 2017, but I've been doing that since 2015. And I've actually accumulated a lot of different things. I try a lot of small projects, small ideas and stuff like that. A lot of them are unfinished, some of them are finished. And what I wanted to do, I wanted to go back in time. And see and look at those projects, see if they're still working, and maybe extend them, maybe do something with them, and so on and so forth. As you can see, I have 6 pages of the projects over 6 years. Yeah, so 1 page per year. So I'm developing 1 page per year. And what I want to do today, I just want to go ahead and just go back in time, back to the beginning. As you can see, I've already been programming in Rust, apparently. And let's take a look at the first projects that we have. And my window is completely unaligned. So yeah, let's take a look. So tic-tac Rust, I did tic-tac-toe in Rust. So some sort of a ping pong. Let's actually go back, like what was the sort of the first project? The problem is that every time you touch the project, you commit something or interact with this project, it actually pops up back at the beginning, at the top, right? So it becomes like a high priority. So it's sort of like a LRU cache, right? It's a LRU cache. And because of that, if you go back in time, you're not getting the project basically the oldest project. You're getting the project that you didn't touch for the longest. And the project that you didn't touch for the longest was updated last time in 2016. It is written in Rust, and it's called Blurp. So that's what we're starting with today. I suppose, well, we have 2 Rust projects in here, and we'll take a look at them. And I suppose that gives me an opportunity to put Rust in the title. So looking into my old Rust projects. There we go. So we're doing Rust today. How about that? Today is a Rust stream. Chat, hello. We're doing a Rust stream today. And the first project we're looking into is called Blurp. It was written in 2016. It has no description, it has no readme, it uses cargo, as far as I can tell. It depends on Gilium SDL, and SDL. So I have no idea what is a Gilium. I don't remember. It's one of those libraries that are already dead. No, it's not really dead. Right, so it was 9 days ago. It was updated 9 days ago, which is nice. So it is still working. Cache, subscribe for 14 months with tier 1 subscription. Thank you, and welcome to our epic Rust club. I know that you like Rust, and that's exactly what we're doing today. We're doing Rust for whatever reason. Okay, I have no idea what that project is, so let's actually go ahead and clone it, right? Let's go ahead and clone it. And maybe I already have it cloned. So let me take a look. So do I have Blurp? I do have Blurp. Okay, so here's the project. It's a git status, right, and what's inside of this project? I think that's literally it. I was trying to build it, yeah, I think I was just trying to build it relatively recently. So it literally has 1 commit. Okay, let's actually try to build it one more time and see what's up with that. So you always have a very pleasant experience with Rust. The builds are super fast. It's a world great package system. Yeah. Multiple package link to native library SDL2, but native library can be linked only once. Well, apparently this project doesn't build anymore. I don't know what's up with that. So if I fetch the latest stuff, I don't think I have any latest stuff. There's only one commit in there, and I can try to clean everything just in case. Right, and there we go. So let's try to build it one more time. So it is fetching some shite. It is fetching some shite. Holy fucking shit! What the fuck is that? Like, is that? It's an index of all of the packages in crates.io, I suppose. That's what it is. Yeah. Fascinating. 35 crates. Okay, so yeah, it's not even buildable anymore. So yeah. Essentially, I'm not sure if Rust at the time was stable. Maybe it was not stable, that's why, so maybe there is an excuse for being this way. But let's take a look at the project itself. So what's this project? So we're initializing SDL context, we're initializing video subsystem, we're creating a window and Gilium. So we have a vertex, right? So, and then we're implementing something for the vertex or whatever. So we're creating the vertex buffer. Then we have some sort of shaders, right? And in a shader, in a vertex shader, we just set up the positions. In the fragment shader, we just set everything to a red color. Then we're compiling the shaders and then organizing the loop. I suppose what I did in here, I just tested the Gilium. Right, I just wanted to see how Gilium works, and that was basically the test. But unfortunately, this thing doesn't even work anymore, right? So you use some piece of technology, and in 5 years, it's useless. It's just straight up useless. You cannot even compile. You cannot do anything. So this project is basically a tombstone, right? So I'm gonna leave this project in the description just in case. So maybe you have motivation and time to revive this project, right? And maybe make it compilable in 2021 somehow, but I don't know. The dead project that does not compile in 2021 Sudge. Yeah. Sudge. So it's going to be HTTPS. There we go. And maybe for people in the chat, I'm going to actually put it in here. So let's go ahead and take a look at the next project. So the next Rust project was something about midpoint circle visualization. And it even points to a Wikipedia article about midpoint circle visualization. Oh, that's actually pretty cool. So, oh yeah, I remember this one. Fuck, I do remember this one. Yeah. So I was implementing midpoint circle visualization algorithm for Demooper. Right, so midpoint, so how do you spell it? It's a midpoint visualization algorithm in Rust. Old, there we go. So here it is. So I have another project that I developed in Rust. It's called Demooper, and it's actually super cool. Right, so it looks like this. You can find it in here. So it's essentially digital music looper. Yeah. So it's kind of dead. I wanna revive it at some point, but I'm not sure if I'm gonna revive it in Rust. Maybe I'm gonna be using a different language. We'll see. So we can take a look at what it is. Essentially, it hooks up into your MIDI controller and some sort of like software synthesizer. Right, and what it allows you to do, it allows you to capture the MIDI events and just loop them with a particular BPM and stuff like that. So people who watch me for quite some time didn't know about this project, but for those who didn't, we can watch a small demo that I actually recorded back in the days. Right, so here it is, you can find it in here if you're interested. We can listen to it. It's actually pretty short. Just a second. I probably need to make it a little bit louder so we can hear shit. So you can see that it basically captures everything and repeats. So yeah, and that was basically written in Rust. Yeah. So, and the next time somebody asks me, Zozin, what do you think about Rust? Have you programmed in Rust? Just show them this video and say, this thing is written in Rust. So, and there's another one, Freefu actually suggested to take a look at at the one where I did outro song, right? We can take a look at that one. By the way, did you know that my biggest achievement in my entire life is making a video that got 2.5 million views? Anyway, so yeah, so the outro. It was also made with Demuper. Actually, I want to play something that I played last time. So you can find this thing in here. Just a second. How I made my outro song, essentially. There we go. So what software synth I used? I used, I think, QSynth, and QSynth also uses something else. I don't quite remember. It's a fluid synth. Yeah. So essentially, I was running the instance of a fluid synth as a separate process, and I connected the two fluid synths via jack, the sound server. So I developed this thing a long time ago. I'm not really. I was not really a good developer at the time. So if I were to start this project today, I would develop the synth completely from scratch, and would embed it into the application itself. So when you start the application, you don't have to set up anything, you don't have to connect anything, you just start the application, it picks up your MIDI controller, and you can start looping and doing things. So if I ever were to restart this project, this is how I would do that. Luckily, I have way more experience these days. I have enough knowledge to actually write my own synthesizer, and that's what I would probably want to do. But back in the day, I was actually very stupid and inexperienced, so that's the only thing I knew how to do. So yeah, so you can find this thing in the description as well. I'm going to put it in the description. So getting back to the circle, what does it have to do with the circle? So QSynth, synth I used for Demuper. Well, you may find a very interesting thing in the Demuper itself, in a screenshot of the Demuper. So it has like this little circle in here. It's actually written, I think there is a mistake in the implementation because it looks very scuffed. It doesn't look very circular at all. But basically, if it's solid, if it's completely filled with the color, that means you're currently recording, and if it's you know, hollow, that means you're not recording. That's basically the entire like UI element, and it looks so goddamn fucking ugly. Like holy shit! Like I would not make it look like that in 2021. That's for fucking sure. And I was using SDL. I think I was using SDL. And SDL doesn't have a way to render circles. So what I did I do? I googled how do I render circle myself, pixel by pixel, and I found midpoint circle visualization algorithm or something, and I just implemented it, and I just basically copy pasted it into Demooper. I kind of like vaguely remember this thing. So yeah. That's what it is. That's what it was. It uses SDL2 for visualization, which is kind of interesting. So I suppose I used SDL just to test things around. Let's see if this mother flipper still compiles. Midpoint. I still even have it on my machine, so apparently I went through that at some point. June 2020. Maybe I was looking through through my old project as well already. So it's kind of interesting. Let's try to fetch the other stuff. Let's do git clean just in case, yep, lock, cargo build. All right, so there's no music apparently. By the way, let's listen to some music. Yep, lock, clock. Well, it's downloading things. Num traits. You need a separate package to have integers. How about that? Oh boy. And it doesn't compile anymore. That's very interesting. Unwind the safe is implemented for, but not for mutable i32. So this thing does not even compile anymore in 2021, apparently. But this doesn't compile because of some, yeah, I think API changed at some point. And the question is, why the fuck do I even need a catch and wind? That is so weird. Let's actually take a look at this thing. So maybe we can fix that thing. So what does it say? Let me actually recompile it from my Emacs, just in case, so I can go through this entire stuff. So this is unused import, we can remove it right away. Point is also unused for whatever reason, so let's actually also remove it. A catch and wind. So the question is, like, why do I put catch and wind in here? Why do I even care? Wait, what was the catch and wind even? Like, why did I do that in 2016? So doc lib rust. So I don't remember what is a catch and wind. Maybe it's something that I basically copy pasted from the internet. Catch and wind. So something about panics, and basically it catches the panic. And why I wanted to catch the panic? Because I wanted to suppress it. You know what? I think at the time I was an active Java programmer, and basically my Java programmer brain said, wrap it with try catch. So, and that's what I did. I just wrap it with try catch. That's basically what it is. That's the reason why this thing exists in here. And I suppose in 2021 it basically broke and it doesn't work the way it worked. So maybe it's not needed anymore. So let's take a look. Okay, so I'm gonna straight up remove this thing and see, maybe it will finally work again. So I don't think you need to catch this kind of stuff, and it just compiles. Yes, you didn't need catch and wind apparently, whatever the fuck that's supposed to mean. But I suppose it just basically catches the panic, whatever it is. Alright, so we have a couple of warnings in here, so we don't use catch and wind anymore. So points variant is never constructed, which is kind of weird, but maybe I'm using it. Yeah, I'm using it somewhere. So basically I have two modes between which I can switch, which is fine. So maybe I can say warn, like allow dead code for this thing. Can I just say like allow that code, because that's what I want to have in here, right? Just allowed to be never constructed. So convert the identifier to uppercase, notice the capitalization. Okay, so unused result. Well, in that case, I can simply probably unwrap this entire thing, right? Because this entire thing can fail, right? Wait a freaking second. Feel erect, but I'm... Wait, am I visualizing the circle with midpoint circle visualization algorithm with the rectangles instead of pixels? Is that what I'm doing? Okay, that was 5 years ago. Okay, I was a different person, and I'm definitely a better developer today than I was 5 years ago. Yeah, basically all pixels are rectangles. Like, this is actually super fun. I should actually do that more often. I mean, you know what they say? If you look at your old code and you cringe, that means you are improving, am I right? So I'm looking at this code and I'm cringing so hard. Like, what the fuck? Why the fuck would I do that? Maybe that way I could sort of scale these things and make the pixels bigger. In that case, it makes sense. But you could basically render it into a texture and then scale the texture. But I suppose at the time I didn't know how to work with SDL textures. So SDL has a pretty cool feature, SDL textures, right? And you can basically take like a bunch of pixels, array of pixels, put it into the texture, and then stretch it, rotate it, and like bleed it onto the screen however you want. What I would do maybe today, if I were to use SDL to render this kind of things, I would render the pixels into array, put it into the texture, and if I needed to scale the pixels, I would just scale the texture. You know, I would just go see the texture, if you know what I'm talking about. So yeah, but anyway, let's actually finish this thing and see how it goes. So maybe I feel like it's kind of a useless work. So let's actually not do that. Fuck that. I think I'm wasting time. Rust likes to like force you waste time on things that don't matter because your program already compiles, right? So your program already compiles, so you don't need to do this kind of shit. So let's actually try to run it. And oh, okay, that's pretty cool. It's not only, oh shit. So it's actually rendering like a full, it even has an animation and stuff like that. Okay, that's pretty cool. But I mean, there are easier ways to visualize like a solid circle, if you know what I'm talking about. Essentially, you can basically take a rectangle, right, that surrounds the whole circle. What's the term? When a rectangle is around a circle, what's the verb that we use? How do we describe that? I know the term in Russian, but I don't know the term in English because I studied math in clauses. Is that what it is? Okay, all right. So you can circumscribe. Gotcha, hyper. Okay, so yeah, basically you can take the rectangle that you know, encloses this thing and iterate each individual pixel and use the classical formula, right? Use the classical formula of x squared plus y squared, right? And basically, yeah, you can calculate the distance from the center of the circle to the pixel. And if it's small enough, if it's less or equal to the radius, you draw the pixel. If it's not, you just don't draw the pixel, and it's just like way easier to do this way. Apparently, like 5 years ago, I didn't know that. Right. So yeah, that's kind of funny. Okay, so and to check if I'm right, so if I try to scale this entire thing, if I say that the k is 2, will that actually work and produce more pixelated result? It's actually hard to tell if it produces, so maybe I can do like 10. Let's see, is it working? Is it working? Oh, it doesn't even increase. This is so dumb. Holy fucking shit. It doesn't even make it more pixelated. So I thought maybe I can increase the size of the pixel so I can see how it's like rendered on a low level, on a low resolution, and like put everything properly. This is very, very dumb. If I were to do this kind of shit today, I would do it completely differently. Maybe this is what we can do today. Let's actually, yeah, so let's actually try to do this thing the way I would do it today, right? So with my knowledge, with my experience, can I do it better? Can I do it more interesting? Can I make it like more simpler and stuff like that? How about that? So let's go ahead and do that. So did I actually give you the link to the project? So here is the description. So old midpoint visualization algorithm in Rust, you can find it in here. So here's the demooper. All right, so what language are we going to use today? Rewriting my 5-year-old code in Rust, but it was already you know, in Rust. Okay, so so looking into my old okay, I don't want to clickbait too much. Okay, I have an idea. Rendering circles with Rust. There we go. So we're rendering circles with Rust. That's what we do. So, midpoint circle visualization, but better. So if I were to just test, if I wanted to just test like a visual algorithm today, right? I want to test a visual algorithm today. I need a surface on which I can draw things, right? So these days, to not depend on any graphical libraries, I use something called PPM, right? So I basically use very simple, the fuck is this PPM image format? I'm using very simple image format that you can easily generate without any libraries, right? So it allows you to basically draw into some sort of a buffer, right? And then dump that buffer as an image, and then you can view that image in a image viewers that support this specific format. And for some reason I cannot open this thing. Maybe I can open the Wikipedia. Okay, so the official website is dead. So specifically I prefer the format called P6, right? So the one that supports RGB channels and uses binary format. So yeah, this is precisely the one that we're going to be using today. So, and it allows you just not to depend on any graphical libraries when you just want to test something and you just want to quickly visualize something. Because again, those graphical libraries may be obsolete in 5 years and your example doesn't work anymore. But if you don't have any dependencies, this example will still work and will still produce something that you can maybe view if you have a viewer that supports this kind of format. But this format was 33 years around, and a lot of things still support this format after 33 years. So it's kind of like okay to depend on this format, right? And just speed out this kind of stuff. So yeah. So you can find the description of this format in here if you're interested, right? And PPM image format. So I'm going to be using this for visualization. Let's go ahead and just generate some images, and then once we're able to generate some images, we can try to see how we can generate a circle. So let's go ahead, midpoint visualization, but better, right? So I'm going to start main.rs, and since we're not going to be having any dependencies, right? We're not going to be having any dependencies. We don't need to even use cargo, right? So we can just use the Rust compiler itself, right? And if at some point there will be a movement, no, cargo sucks, we need to change it to a different package manager, which can happen, which already happened in these hype-oriented, communities like in JavaScript. For instance, they have NPM, they have Yarn, right? So it's quite often for these hype-oriented communities to just say one day, okay, fuck that technology, we're gonna make our own one, and now the community is split, and so on and so forth, right? So shit like that may happen to Rust as well, because it already happened in similar communities. Right. So, and if you just don't depend on cargo, you just don't participate in this circus, right? So this is actually pretty good. All right. So let's go. Let's create a simple hello world. white space. Okay. So hello world. All right. So do we have something working? Do we have something working? Is this compilable code? I think it is compilable code. And if we try to run it, right, I think it should say hello world. We're off to a good start. We already know how to print hello world to the console, which is already good. All right. So let's decide at which resolution we're going to be rendering things. Let's actually start very small, right? So let's define like a width. I don't know, around maybe 64, right? So it's going to be width and height. And let's actually allocate an array of pixels, right? So since we're using PPM, PPM supports 24-bit. There is a 32-bit extension. I'm not sure if we're going to be using that because I never used it, so I'm not sure how reliable this extension is, but I use 24-bit format. So since it supports only 24 bits, but it's kind of difficult to, you know, have 24-bit aligns integers in a modern machine. So we're going to use like 32-bit pixels, right? So let's define something like pixels, right? And this is going to be just simply an array of U32. U32 is going to be a single pixel, and how many of these pixels we need? We need the width by height pixels. And I suppose I can just simply initialize this like that. So this is going to be 0, and there we go. We have a bunch of pixels. Right, allocate it on the stack. But since the image is so small, well, it's not going to blow up the stack anyway. All right, so let's try to dump those pixels as a PPM file, right? So save as PPM. Save as PPM. So what we're going to be accepting, we're going to be accepting the file path, which is going to be a string. Then we need to accept the pixels. We're going to accept them probably as a slice. I think this is the easiest thing to do in here. So this is going to be slice of unknown size. And another thing we'll need in here, we'll probably need width and height, right? So there we go. We have width and we have height. There we go. So, and what we're going to do now, I suppose, we just need to open a file. How do you open files in Rust? Let's actually find out. So Rust docs stdlib. So I know there is like a file class or structure or something like that. Oh yeah, Rust developers hate the word class. I'm gonna call it class now. So there is a file class that you're supposed to use. It's located in a namespace stdfs, right? So let's actually use stdfs file. There we go. So this is gonna be something like this. And you can open things. Read only. Okay, so we need to actually be able to write to the file. So I suppose we need create. So in write only. Okay, that's perfect. And this entire thing also returns the result. All right, so maybe we're gonna return the result like this, right? Indicating that like we're not gonna crash within this thing. We're gonna let the caller to actually check this error, you know, this stuff like that. So let's actually open the file. This is gonna be file, create file path, right? There we go. We managed to create it, and then we're gonna basically use a question mark. So essentially what the question mark means, if you return a result or an option, and if it's like failure or something like that, it will instantly return from the function with the failure result, and then you can check this kind of thing. So the way we're going to be calling this function, by the way, is like this. So what's going to be the output path? Something like output path. Can I actually use constants for that? I think I should be able to. So this is going to be output ppm. There we go. So this is the output path. So then we take the pixels. As far as I know, if you take a reference on an array, it basically converts to a slice automatically, right? Taking a reference to array is basically converting it to a slice. So it should work, if I understand correctly. If I remember correctly, I don't know. I don't program in Rust, I'm sorry. So the last time I programmed in Rust was in 2016, right? So what do I know about Rust? Okay, that looks good. So the next thing we need to do, we need to write a special header into the file. So if I remember correctly, the formatted writing is write-len. It's almost like a print-len, but for things that implement like a write interface or something. I don't know Rust, I'm sorry. So I think that's the thing I need in here. Yeah, so you can write in vectors. So vec implements a write interface, so you can write shit into a vector. I suppose specifically vector to a string. Maybe, yeah, you can write a vector to a string. Okay, that's pretty cool. So it's like a send printf or something, but with a global vector. But this is not what we need right now. So what we need right now, we just need to do something like p6. Then we need to put a new line in here. And since we're taking new line control in our hands, I'm not going to use right len, I'm going to just use right. So the next thing we put in here, we put width and height and the size of a single component. I usually use 255, like it's always 255, so I just treat it as a magical number. So, and in here, I just provide width and height. There we go. So let's actually test if this entire thing even compiles and even works. So probably doesn't, right? Because we'll have to import a bunch of things. Okay, so width, all right. So format argument must be a string literal. Oh, yeah, so I have to provide the file. Okay. So what's the next thing? This enum takes 2 generic arguments, but 1 was provided. So I think this is because we're using wrong result, right? So if I take a look at what right, so file, let me take a look at the file. File returns its own result, and it probably returns the result. Yeah, it returns the result from like stdio or something. So maybe the thing we're gonna use here is stdio, right? And we can just put this thing in here. There we go. We're using stdio. And to indicate, by the way, the success, we need to return OK in here, and maybe we also have to put, question mark in here. So method write not found into the file. So, oh yeah, we probably want to import something like use stdio, right? And is it going to work? It seems to be working. Okay, so we're not using pixels right now, but this doesn't matter. File cannot borrow as mutable. Okay, so this thing has to be mutable then. And we managed to finally write into a file in Rust. Look how easy it is to just write into a file in this beautiful, beautiful language. It's super easy. You see how little you have to do just to write a single line to a file. It's super, super easy. Let's just try to run this entire thing. And it generated the file. Let's take a look inside of this file. And there you go. You have the ppm magic number, the size of the image, and the size of the components. You don't have the pixels yet because we didn't write the pixels yet. But you can already have this kind of stuff. You see, it's a beautiful, beautiful and easy. Easy. Don't you guys like this language? Rusticians are molding. Ah. Anyway, so now we need to write the pixels, right? So essentially, you have to write 3 bytes, right? You have to write 3 bytes, R, G, and B. So what I want to do actually here, I want to be able to use the color codes in a human readable order. Basically, I want to use literals like this, RR, GG, BB. So that means this byte, the third from the right byte has to be green. The second from the right has to be red. The second from the right has to be green, and the last one has to be blue. Right. So let's actually see. Yeah, maybe we want to actually fill the entire thing with something. Can I actually fill arrays in Rust? Is that a thing that you can do? Is that a thing that you can do? You can fill a slice. Well, I mean, array can basically become a slice. Maybe it can use this kind of stuff. So let me actually try. So this is going to be pixels, and then we're going to fill, not will, but fill this entire thing with what color? I think we're going to use red color because it's the color of the communism, right? So we're filling everything with red. So we're filling everything with the red, and the next thing we need to do, we need to iterate through all of the pixels, right? And we're gonna iterate by rows, right? So it's gonna be 0, right? Something like this. This is gonna be X in width, right? And how are we gonna be doing all of that? So if I suppose I have a write interface, right? So if I take a look at the write interface, it's FMT or IO, FMT or IO. I'm not sure. Like, is there any difference between them? Maybe there's no difference. I think there is. I think I don't remember it being like that. Oh my god, it's so slow. Holy shit. Why is it so slow? Okay. Oh, all right. That's cool. So we can have a buffer. Can I write a single thing in there, or can I only write like a buffer? Maybe it doesn't matter. Maybe it doesn't matter because I can accumulate all of the components into array and then write them as a buffer. I think that's going to be the easiest thing to do. Okay, let's go ahead and do that. So first of all, I would like to extract the pixel that I'm about to write. So it's going to be pixels, and this is going to be y multiplied by the size of the row plus x, and there we go, we got the pixel, right? We've got the pixel. After that, I need to create maybe the buffer, right? Maybe I'm going to call it color, right? So, and as I already said, I want this to be a red color. So to get the red color, we need to get the pixels, shift it 2 bytes to the right, right? So the first shift will get rid of this byte, the second shift will get rid of this byte, right? So we do 2 of them. And then what I have to do, I have to apply a mask that removes everything else that is potentially there. So it's going to be FF, so this is the red component. So the next one is basically that, but with a single shift in here. So this is going to be 1, and then we apply the mask, right? And then the last one is basically with no shift, right, something like this. So this is going to be 0, and this is going to be 0xFF. There we go. So here is the color, and we have a buffer that we can probably now write into the file, right? So let's see if it's going to work or not. So this is going to be color. Maybe it's going to be, yeah, let's call it color, whatever. Okay, so, and this entire thing, of course, may produce an error, so we have to put a question mark in here, right? So let's actually try to recompile the entire thing. So this is going to be rust-c main.rs. Oh, okay, this one is very interesting. All right, so the result of this entire thing is U32, but it expects U8 because it wants bytes. So I suppose after we extracted everything, we have to convert everything to the byte, right? Otherwise, it's not gonna properly work. As U8, and then another one as U8. There we go. And it seems to be working, and if I run this thing now, let's actually also rebuild and run it simultaneously, and I will open this thing, we'll see a red square. Boom! Got cooler, by the way. So now I can also increase the size of the square. So you see, you don't need any dependencies, like we're not using even cargo or any libraries or anything like that to just print, like just display something on the screen. If I usually have like some sort of visual algorithm that I want to test out, and I don't want to mess with all of these libraries, with all of this build system, I just want to test a thing, I use ppm format, because the entire routine that saves a thing into ppm format is this. Even in Rust, it's just this. In C, it's probably going to be smaller, but yeah, maybe it's going to be even bigger. It depends, because you need to like check, but it doesn't matter. So yeah, it's actually super convenient. So this is the entire graphical library that I use these days to just visualize things. Pretty convenient, unless you need something like interactive, right? If I don't need anything interactive, I just use that. It's really convenient and do recommend it. What image viewer? I'm using Emacs. I'm literally viewing this image in Emacs, believe it or not. Right, so, but you can use Fer. Fer also supports this thing. So I'm gonna set background, I think it's B, black. Output ppm. Yeah, you can use Fer if you want to. So in Fer, it's even a little bit more God damn it, did I close Emacs? I think I accidentally closed. No, I didn't. All right, so I can open it like that, right? And then I can do the following thing. I can just keep it in here, right? And then I can try to change the color. So now let's actually use green one, right? So I can recompile the program, rerun it, and update it. There we go. So it's actually bigger now because I changed the size to 512. So I can probably make it a little bit smaller, 256, right? 256, and there we go. Now it is smaller. I can do some other things. So yeah, no dependencies, by the way. No freaking dependencies. Look at that. Rusticians are molding. They're molding how little dependencies this code use. They're fucking mad, because you're supposed to use shit ton of like libraries, like a very complicated build system just to get like a green square on the screen, but we're not using any of that, and we already have a green square on the screen. So, all right, so let's actually try to do something more complicated than this. Maybe we can write a function. That produces a checker pattern. So let's go checker pattern, right? So, and this thing is going to be pixels and u32, width, u size, height, u size, and there we go. So to be fair, I think this thing should accept slice mutable because it's going to be modifying it. And let's just iterate through the entire thing. So this is going to be y in height, right, for x in width, right, for x in width. And what's the next thing we're going to do in here? So I suppose so we need to know the size of the grid, right? So we may probably provide the size of the grid via the arguments as well. So grid size, maybe tile size, right? Tile size, and it's going to be u size as well. So in here, what we do, we're going to take x plus y, and we're going to basically divide it by the tile size, right? We divide it by the tile size. Maybe I could actually do that separately, but if I do this thing separately, it's going to be pretty much the same thing. Okay, so, and after that, I'm checking if this thing is even or not, right? I'm checking if this thing is even or not. If it is even, then I'm going to use the, let's say, background color, right? So background, let's call this background. Otherwise, I'm going to be using foreground, And what I'm going to do in here, I'm going to be assigning all of that to the current pixel. So it's going to be y multiplied by width plus x, and there we go. So, and we're going to accept foreground and background via the arguments as well. So it's going to be foreground and background u32. Right, so all of that stuff becomes customizable. Hopefully that will work. We'll see. So instead of filling everything up, we're going to be using checker pattern, right? We're going to be using checker pattern like so. Why didn't copy it properly? So we're going to be taking the pixels, right? So I'm passing the pixels in here. Then we're taking the width, which is going to be this width. Then we're going to do that. What's going to be the tile size? What's going to be the tile size? I think we can put something like 10 in here. The foreground is going to be red. Let's put red in here. And the background, let's make it black. Right, so this is going to be the black background. Cool. So let's see if this entire thing compiles. Probably it doesn't. No, look at that. It actually compiles. And oh yeah, I never actually, well, yeah. So I'm filling the checker pattern, and then I'm filling it with green again. So let's actually not remove this line. I have an idea. So I'm gonna always fill the pixels with green, just to check if the checker pattern worked correctly. If it didn't work correctly, if it missed any of the spots, we will see bright green color. So this is kind of like a trick that game developers use all the time, right? So they basically have a very bright background, and if there is something that is like missing, it becomes apparent. So quite often people use like magenta or green or something, so it's like, you know, jumps into your eyes instantly if you forgot to like cover some spot in the scene or something like that, right? So it's quite common trick actually. So all right, this doesn't look like a checker pattern. And well, it's actually pretty cool pattern anyway. So it's like stripes, and I think I know precisely why it doesn't look like a checker pattern. But it looks cool nonetheless, you know. You know what? I'm gonna actually leave it. It's like a PewDiePie pattern, but it's actually straight. Yeah, because the PewDiePie logo is usually gay, but this one is straight. So anyway. Yeah, let's actually stripes pattern, and let's do the checker pattern. Maybe I'm gonna even copy paste this entire thing. Right. Did it copy paste? I think it did copy paste it. All right. So this one is gonna be checker pattern. And to do the checker pattern, I think we have to actually basically do it like that. We have to do divide tile size for each individual component in here, right? For each individual component. I heard NFT. What is NFT? Is that something monkey to us? All right. So checker pattern. Let's actually replace. Oh yeah, I already used checker pattern, but we also have stripes pattern. Okay. So if I take a look at this thing, there we go. We have a checker pattern. Look at that. So look for that. That's actually pretty cool. And you can control the size of the tile, right? So if you try to run this thing, well, it's actually quite big now, but yeah. So 256. So to actually match the size of the tile and the whole thing, right? The size of the tile I think has to be like a power of 2. Let's actually use 32. Right. So and boom. And if I do that, yeah, now it matches perfectly. That's cool. Like magenta, okay, so we can do that with the magenta, sure. The color is controlled here, so here is the foreground, here is the background. Magenta, as far as I know, is red and blue, right? It's a red and blue, and boom, there we go. So now it's a missing texture. What should I read to learn more about working with pixels without being language specific? That's a good question. I don't know. I don't know if any of the tricks I show here are written in a single book, right? Because I sort of gathered all of these tips and tricks over the years of software development from different languages, different libraries, different projects and stuff like that. So it's just like a accumulation of all of my experience. And yeah, I wonder if somebody actually made something like that. Maybe to work with the pixels, you may want to learn how to work with the bits. And there is a pretty interesting book on that topic. I think it's called Hacker's Delight. Hacker's Delight. I don't remember how to spell that, but yeah. So essentially, it's a book on tricks, tips and tricks on how to work with bits, numbers, and stuff like that, on these low-level things like shifts and for instance, maybe to know that that if number is divisible by 2, you have to do AND 1, and that tells you that it's divisible by 2. It's the book that filled with tricks like that. As far as I know, I never read it myself, but I heard a lot of good things about it. So so is there any description? So time-saving techniques, okay, let's take a look at it. Time-saving techniques, algorithm tricks that help programmers build more elegant and efficient software while also gaining deeper insights into their crafts. Practical, they also intrinsically interesting, sometimes unexpected solution, great puzzles, and so on and so forth. So I suppose this kind of book can help you to learn this pixel stuff, but I'm not sure if it's related to pixels, you know, themselves, right? So it's more about working with bits and whatnot. So it would be nice to take a look at what they're talking about. So what are the topics of this book? Right. Yeah, things like manipulating rightmost bits, addition combined with logical operations, average of 2 integers, sign extension, shift right sign from unsigned, sign function, decoding S0 means 2, and there's a lot of things like that, rotate shifts, and this is an entire book about that, right. So it's not about information security, it's not about, you know, hacking per se, it's more about like these bit magical things. So you can find it in here, and I wish I had time to read it myself, actually. Thank you for reminding me about it. Yeah, I want to read it about this book at some point. Read this book at some point. Okay. Let's put it like this. Hackers Delight. There we go. So it's gonna be in the description for lovely people who's watching me on YouTube. All right, so let's take a look. So as you can see, now we have a framework to put something on the screen, right? So this is basically the whole framework to put something on the screen and to experiment with visual things, right? Visual things. So the next thing we probably want to do is to render a circle. So how would I render like a solid circle today? If we're talking about solid circle, right? So I will just use this technique where I basically iterate through all of the points that are close to the center and just use the, you know, x to the power of 2 plus y to the power of 2 less than r to the power of 2 to determine if it's close enough. And that way I know if I want to put something there or not put something there. So that's the easiest way to do that. So let's actually create a function called solid circle, right? So maybe something like fill solid circle. We're going to accept the pixels. Of course, we're going to accept them as mutable. Right, and width, this is going to be width, use size, then height, use size. And we also need to accept the radius, right? So this is going to be radius, use size. So the thing I want to do now, right? So if the radius is too big, maybe it doesn't matter. Maybe we're going to be iterating through each pixels, right? And we're never going to go out of boundaries in here. So there's no reason for us to check anything at runtime. So the compiler should be able to optimize that out. All right, so let's actually start iterating through the entire thing. Right, like so for x. It's actually not equals, it's actually something like in, then this is going to be width, right? So, and we need to know where is the center. Well, let's do something like let cx is going to be divided by 2, right? And cy is going to be height divided by 2. There we go, we have the center. So now we need to find the difference between x and y. So this is going to be cx minus x, so this is the difference. And then query replace x, y, there we go, we have y. So, and I think I want to check now, if dx, double dx plus double dy is less or equal to double radius, you know, let's actually rename radius to r, right? Because it will make it easier for us to actually write something like this. There we go. If it's less, right, we're gonna do pixels y multiplied by height plus x, and here we need to put I suppose foreground color, and otherwise we're going to put a background color. There we go. So that's the whole thing, and we can actually provide foreground and background as parameters for this function. So that's the whole thing actually. So I don't think you need too much to just visualize the solid circle, right? It's a pretty straightforward task, I think. Right, so this is the checker pattern. We're not going to have a checker pattern. So you know what, maybe I'm going to actually extract this foreground and background colors to constants, because I keep using this like notion of foreground and background. I think that would be kind of useful. So this is going to be foreground U32. So in our case it is basically magenta, magenta. And this one is going to be foreground and background. There we go. So, and let's take a look. This is going to be mutable. This is going to be width, right? This is going to be height. The radius, let's say the radius is going to be maybe half of the width, right? So this is going to be half of the width, then the foreground, and then the background. There we go. So let's comment out the checker pattern, and here we fill in the circle, and let's see how it's going to go. So here's what we have right now, and let's try to compile this entire thing, and it didn't work for some reason because it didn't compile. Okay, so panicked attempt to subtract with overflow. God damn! So we have an overflow. So the all right. So the reason why we have an overflow is that both of these things are, Yeah, they are essentially uSizes. They're unsigned integers. So, and I suppose one of the things we want to do in here, first, I want these things to be as I32, and this one is going to be as I32. So we want them to be signed. We want them to be signed. You guys heard my real voice, huh? Okay. So, and after that, it's going to be as I32. And R, unfortunately, I want this thing to be positive. Yeah, I have an idea. Let's actually do it like this. So this is going to be a radius, but for the R, it's going to be a radius as I32. So this entire thing becomes basically I32. So we're doing all of the computations in signed, but we accept parameters as unsigned. So that way we can go to negative and stuff like that if we want to. Right, and boom, it actually filled everything, which is rather sus, not gonna lie. So maybe, well, it's not supposed to be that, right? It's not supposed to be that, but it is. So this is the, so this is the position, half of the width, half of the background, a foreground are the same. Ah, that explains it. Thank you so much. Thank you, Consar. I didn't see the nickname who said that, but I just saw that. Somebody said that. Boom, there we go, we have a circle. So, yeah. So, that's how easy it is to render a circle, a solid circle. You just use this technique, right? And you just check if the pixel close enough. That's it. So, that's how we do that. But the question is, like, how do you do a hollow circle? This one is already interesting. How do you do a hollow circle? This one is not really that clear, in my opinion. Okay. So I wonder if you can remove the interpolation in Synth. Does anyone know if it's possible to remove the interpolation? So this is going to be man Synth. So what is it called? Interpo filter. Disable filter. Pull requests. Anti-aliasing. I'm not sure if it's anti-aliasing. Disable anti-aliasing for zooming background. Yeah, okay, so it disables already. So we can try to do something like this. Force aliasing, right? Oh, perfect, thank you so much. Yeah, yeah, this is precisely what I wanted, because I want to see them pixels, right? I want to see them juicy pixels. It actually looks kind of sus, not gonna lie. But I suppose on a bigger resolution, all of these weird things that pop out, not gonna be that much visible, if you know what I'm talking about. So maybe it actually depends on the resolution, right? Maybe we have to sort of calculate the distance from the centers of the pixels, if you know what I'm talking about, maybe to make it like a little bit better. So I think I know what's going on. Yeah, I actually know what's going on. Okay, so essentially, if you have the grid of pixels, right? The grid of pixels. So we're gonna have 9 pixels, 3 by 3. How we wanna compute the distance between the pixels? We wanna actually compute the distance from the centers of the pixels, like so, right? And just check if that distance actually, you know, short enough or long enough. Because right now, since we're using the coordinates of the pixels, that means we're computing this kind of stuff. So everything is sort of offset, right? So we're computing this sort of distance, and maybe that's what's causing that, but maybe I'm not sure if it's that important or anything. So I'm not gonna rat hole on that for too long. Okay, so this is how we do that today. So do you guys want this code? I can probably, you know, upload it somewhere. The question is where I'm going to upload it. Do I want to upload it to the same sort of project or to a different one? maybe I can actually upload it to the same project, right? So create two separate folders, the old folder, right, and the new folder. So that would be actually kind of cool. Yeah. As you can see, you can have like different patterns. You get stripe pattern and so on and so forth. You know what? Let's actually go through other patterns in here. So here's the checker pattern. Right. So I'm gonna do that. Yep. Cool. So this is the checker pattern, and then you can have the stripes pattern. You can do that. Boom, here's the stripes, and I just want to keep them in the code in a commented form. So if you want to just, you know, check them, you can just uncomment the corresponding line and just see how it basically does the thing. Yep, so that's pretty cool. And you can control the resolution if you want to like make a smaller resolution. We can see how the circle looks like on a very small resolution, like maybe 16 by 16, how the circle would look like in that resolution. And we can zoom in really far, and there's, yeah, you can clearly see that. That's precisely the effect I was talking about. Since we're basically measuring the distances between the left top corner of the pixel, the entire image is slightly shifted to the left, right, up. You see what I'm talking about? This is so cool, right? So honestly, 5 years ago, I wouldn't even think about details like that. So I think the thing that made me a better developer over 5 years, I'm actually thinking about more details like this, right? I'm just noticing more details. I like fixated on more details like that, because like 5 years ago, I wouldn't give a shit. Honestly, I just wouldn't give a shit, right? I would just like slap something that works and fuck it and just, yeah, there we go. But now I'm just obsessing over this stuff. What the fuck? And I want to fix that. I actually want to fix that. I want to try to do the thing where you would compute the distance from the center of the pixel and just make it symmetrical or something. Man, holy shit, this is so interesting, actually. I wonder how we can do that. So to do that, you need to sort of know the size of the pixel, right? But the size of the pixel is 1, so that means you want to do computations in floats, right? So you want to do computations in floats to compute the distances and whatnot. So yeah. So I want to put a to-do in here. So the first to-do is going to be something like to-do compute the distances between the pixels starting from the center of the pixel to avoid the image of centering on low resolutions. On higher resolutions, it doesn't matter, right? It just doesn't matter because you cannot see these kind of details, right? So yeah, let me take a look at that. So if we have a higher resolution, for example, 512 by 512, right? So we're gonna do something like this. Boom. You cannot even see that the entire circle is sort of offset. You can't see that because how smooth it is, right? But with low resolutions, you can actually see that. Harry's Delight book is awesome. Thank you, Tojing, for the recommendation. You're welcome. I actually recommended something that I never read, but I actually, like, I only heard good feedback about this book, and I read the table of content. So, and from the table of content, it looked interesting enough for me, and that's why I recommended it. All right, so let me see. So this is going to be the first to do. The second to do that I want to implement is a function, a similar function, right? A similar function with a similar signature. It's a similar signature, but midpoint visualization. Yeah, basically draw circle. Let's call it draw circle. Fills circle, draw circle. Yeah, there we go. So because I want to see how can you implement the midpoint drawing algorithm, midpoint visualization algorithm, from the point of view of 2021 me, right? So I already know how we'd implement it in 2016, right? And it's pretty crappy, not gonna lie. My 2016 code is pretty meh. I'm not proud of it. especially this part with rectangles and shit. This is cringe as fuck. So, and I still don't know anything about this algorithm, by the way, right? So, and I remember when I was implementing this algorithm, I didn't understand shit. I didn't understand shit, and I just basically copy-pasted it from somewhere. I just made it work, and then just copy-pasted it to my main project, right? So, can I understand this algorithm today? Do I have enough experience and knowledge to understand this shit today? We're about to find out. Maybe I have enough experience and knowledge to understand. Maybe not. I don't know. So let's actually do something like to do. So this thing is not implemented yet. And might as well just copy paste this entire thing. And this one is going to be draw hollow circle. And if I try to run this entire thing, it will say, bruh, didn't work. So none of these things are working. I really hate warnings of Rust because they make me obsess about not important things, and I hate it. I really hate that how it makes me obsess over not important things. It's just insane. Yeah, maybe I'm not gonna listen to it. All right. So before I'm gonna go ahead and do all of that, I want you to make a small break and make a cup of tea. So yep. Let's make a cup of tea. All right, let's try to, I don't know what's going to be the next thing that we're going to do. I think the next thing what we're going to do is we're going to be moving this stuff to the repo, Midpoint visualization. So I'm going to put it in here, and let me do git clean fdx. Right. So I'm going to remove all of this. Did it actually remove anything? I think something didn't work. Clean fdx. There we go. Now it worked. So the thing I want to do in here is I want to create old. All right. So, and we're literally going to be moving this stuff here. Yep. And we're going to have a new. Right. So old is going to be 2016 and new is 2021. Right. Basically 5 years later. Right. So we want to preserve the history, right? We want to preserve the history. So in here, we're going to have a single file, believe it or not, it's just like a single file. Just copy it in here, there we go. Here is the single file. So to actually not confuse the files, I'm going to remove this entire folder. It will ask me to kill all these buffers and whatnot. Right, so there we go. And I want to write some sort of a README. So I suppose, did I provide any license for this kind of stuff? I think I didn't. Yeah, there's literally no license. So it was out there without any license. So I'm officially releasing license this entire stuff under MIT. I'm also gonna actually swap these words like this so it is sorted correctly. Right, there we go. Basically something like this. Midpoint circle visualization in I don't know, demo. Okay. Implementation of the midpoint circle visualization, right? And we're gonna give the link to this kind of stuff like this in Rust, right? So, and this is gonna be Rust, Rust lang, or is it as Rust lang? Yeah. Chromium doesn't allow me to actually autocomplete this stuff. It wants me to type it out, yeah, character by character. Thank you, Chromium. Very cool. So, all right, 2016. I don't know. What should I put in there for different folders? I suppose. I don't know. Maybe I'm gonna put like readmes in here. Readme. Okay. 2016th 16th attempt at the implementation Okay, kinda crappy, but it does something. Right, so, and then we're gonna have a quick start. Right, so this is gonna be a quick start. And here we're gonna have a console, basically a cargo, a run, and that should be it. Right, so this is a cargo, a run. This one, okay. To 2021's attempt. I'm not sure if I should put S in here. Another attempt to implement the algorithm in 2021. No dependencies, single self-contained Rust file. Right. Visualization is done via outputting ppm images. Right, and we're gonna give the link to this kind of thing in here. So that's what we're gonna have. So the quick start is going to be quick start console. Just do rust c main rs and just run rs. There we go. So it's as simple as that, and we can also git ignore main and output ppm. Maybe like all of the ppm files. Maybe we're gonna output more than one ppm file. You know what? We can actually, yeah, maybe for each of these things, we can output like a separate file. Why not? I don't see any problem with that. Right, so essentially we can have stripes. So we fill everything with green color, then we do stripes pattern, and then we save everything to something like stripes ppm, right? So then we do that again. This one is going to be checker ppm. Then we can have solid, and then we can have something like hollow. There we go. So yeah, we can output everything. Why not? So just you can check all of them, and that way we're using all of the code, which is nice. So if I try to do this thing, wait a second. So this is going to be something like rust c main rs, and let's just run this entire thing. Okay, so, and it printed all of them. So here's the checker pattern. Oh, okay, so you can clearly already see that checker pattern doesn't use a background color. So then we have stripes that also doesn't use a background color, and a solid, which is already broken, which is nice. Okay. Oh, this is because, yeah, I actually did experimentations off screen, which actually revealed this bug that I wanted to fix on screen because I wasn't recording at the time. So yeah, I actually supposed to use width in here and not height, because we're iterating by the rows of the entire thing. We're iterating by the rows. All right, so, and let me try to recompile the entire thing. It would be kind of nice if it outputted the thing that we're doing in here, right? So let's actually take a look. So this is going to be main.rs, and every time we save something, we should say something like println saved file path. There we go. There we go. So, and as you can see, stripes, checker, solid, and then it breaks at hollow. All right. So seems good to me. Seems good to me. So here is the README. Alrighty. So this one is going to be attempt. I really don't like this wording. I don't speak English. I'm sorry. Alright. Another attempt to implement the algorithm. We can say that it was first attempt to implement the algorithm in 2016. Kind of crappy, but it does something. Rendering is done via SDL2, right? Via SDL2. The code was the code stopped working in 2021, so we had to manually fix it. There we go. So I think we're ready to do a committee for this entire thing. All right, come on. So we deleted that, and then there we go. Add 2021 attempt. All right, and I'm gonna push that right into the repo. So now, as you can see, we have two folders in here, old folder and new one, Midpoint visualization demo, implementation of the Midpoint in Rust. Right, so, and for the new attempt that we're currently working on, go to this folder, right, go to this folder, and here is the actual source code that I developed on this stream. So if you're interested in this thing, so here is going to be available in here, and for people who watch on YouTube, you can find this thing in the description, right? So in the description, it's called Old Midpoint Visualization Algorithm. I'm actually gonna rename it to, oh boy, yeah, there we go. Just Midpoint Visualization Algorithm. So here's the source code, right? So now you can test that and try that on your own machine if you have Rust. Chat, why are you dead, by the way? You guys were screaming at me the whole time while I was implementing things, telling me that I'm wrong, but now everyone is dead for some reason. What's up with that? All right, anyway. Let's go ahead and try to fix this problem. So compute distance between the pixels starting from the center of the pixels to avoid the image of centering on low resolutions. Maybe I have to say at low resolutions, right? So let's take a look at the low resolutions. Let's take a look at the low resolution. So this is going to be 16, and let me try to maybe rebuild everything. Since it renders relatively slow, right, for some reason, by the way, I don't know why it renders so slowly. Yeah, it's actually a good question. Why the fuck it renders so slow? Probably because, let me see. Well, this is because it's 16 by 16, right? So with 16 by 16, it's relatively fast. Solid ppm. Okay, so let's go in here and let's see if we can do something about that. So we want to get rid of these pixels. So one of the ideas I have is to actually compute the distance from the centers of the pixels, right? So from the centers of the pixels. Maybe I want to also document how exactly I run the entire thing. Right, so and here we can do something like fech. I don't even know, do I want to say that? Maybe not. Yeah. So do I want to, like I was wondering, do I need to document that? Open the ppm files, the generated ppm files in image viewer. I guess there's no point in documenting that, right? So the application itself sort of tells you, right, that it saved these things in here, right? So the thing that kind of bothers me is the following, right? Why, when I do like 512 by 512, it is so slow? Rust C main.c, it's not .c, it's actually rs, right? So yeah, it takes some time, and 500 by 500 is actually, I mean, this is nothing for a modern computer. And we're not even doing any expensive operations. So the usual thing with the Rust is that when you use cargo, it does not apply optimizations by default. So maybe this is one of the things you want to do. You want to sort of like enable optimizations in the compiler, but since I'm not using cargo, I don't know how to enable optimizations. So optimizations, do you have O? Yeah, it does have O. Okay, equivalent to OC. All right. That's actually pretty cool. So there is OPT level. We can specify OPT level. If I try to compile the entire thing with a particular OPT level, for example 2, will it make it faster? And well, I should have actually run it like so. So if it's gonna be 3, yep. Doesn't make it super fast, to be fair. It would be interesting to compare the implementations in C and in Rust, because I don't think 512 should be that slow. I don't think so. Like, I can't believe that it's gonna be that slow. So you can see each individual file actually being produced. So that's the weird question. Like, why does it take so much time? Is that because I'm safe? Oh shit. Maybe this is because of the output. I think it's I/O. I think it's something with I/O. Let's actually try to confirm that by maybe not doing any I/O. But the thing here is, I still want to see that something is saved because I'm using that information for visualization. So I suppose one of the things I can do in here is probably comment this stuff out. Right, so I can still see the logging, right, and how fast it is. So let's try to recompile that without any optimizations with a regular thing, and yeah, it's saving. Okay, all right. I just have a slow hard drive. That's what it is. That's what it was. So, and if I take a look at the main RS, yeah, yes, it's just a slow hard drive. Can we speed that shit up, by the way? Can I pre-allocate? Yeah, I think we can try to pre-allocate, but because we're doing a lot of small writes, so that's the problem here. We're doing a lot of small writes. We want to basically put all of that into a vector. And vector is actually writable as far as I know. So, but vector also reallocates memory all the time, so it could be slow as well. So yeah, it's kind of interesting. It's kind of interesting. All right, so let's try to compile this entire thing and see how slow it is. Yeah, it is pretty slow. What if we provide some sort of a buffer, if you know what I'm talking about? So essentially, we're not gonna write anything up until now, and when we're writing the entire thing, we're gonna be writing into some sort of a buffer. So, and the buffer is going to be essentially vector of U8, right? Is that how we do that? I think, right? So this is going to be a buffer of U8, and what we want to do in here. So vector, if I understand correctly, it implements the write interface, right? Like Rust std doc. Rust std doc. So. I need to close the chat just a second. So what does it implement? Does it implement the things? I don't see it implementing the things. Well, we can just push these things in there, right? We can just push these things in there, right? So, and that means I can push them like this, right? Buffer push. And I'm not even sure, do I need to do as U8? Because maybe not. We'll see. The compiler will probably tell me if I'm doing something wrong. Okay, so we're basically essentially sort of accumulating everything in the buffer, and then we're opening the file, we're writing the meta thingy, and then we do write, actually file write, and we give a pointer to this buffer. As far as I know, if you reference the vector, it also can be seen as a slice, right? So let's see if this entire thing will speed everything up. So there's compilation errors, of course you have to provide these things in here. Okay, so remove the parentheses. All right, sure, it's very important. Yeah, like I really hate how it makes me obsess over not important. This is not important, holy shit. Okay, so pixel, okay, and it was needed because you still need to provide as you need. Okay, literally waste of time. This entire language is a waste of time. Okay, so file unused, what does it say? Result might be unused. Okay, so there we go. Cool. Did it become faster? I think it became faster. So if I take a look at this stuff, right, it is faster now, and it produces this entire thing. So the main source of slowness right? The main source of slowness was that we were doing a lot of small writes, right? And I didn't like that. So apparently vector, not vector, but file itself is not buffered. So, oh, and there's also buffered writer. Yeah, there's also this thing called buffered writer or whatever. Buff writer, oh my god, yeah. So it brings back all of these like Java vibes. Yeah, you have like a file, then buffered, reader, writer. Like this is literally Java. So yeah, so you also have, you can probably speed it up just by slapping like buffered writer on this entire thing. Yeah, sure. I wonder if we can just do that. So yeah, so here's an idea. So here is an idea. We're gonna go back in our implementation. We're gonna go back into the slow implementation, right? So I'm not sure what exactly I'm doing in here. So did I distance between the starting point? I don't see what I did in here. Maybe it's not. Oh, at. Okay, so I'm gonna actually commit like this typo. Okay, typo. Let's go back to the slow implementation, right? And let's see how slow it is. Yeah, it is slow. And now, what I'm gonna try to do, I'm gonna just try to slap buff writer on that thing, right? So it's gonna be stdio and just buff writer. All right, so can I just do buff writer new and just rub this entire thing like this? Buff writer new. Is it as simple as doing something like this? Well, yeah, you also probably have to check that. Buff writer itself probably does not return any errors in here, so that should be fine. So, and let's just go ahead and do that. All right, so what do we have in here? Writer, and it actually speeded up. Okay, that's cool. Look at that. So yeah, it actually speeded up. I wonder if you can also provide you can also provide the capacity. Okay, so can we know the capacity? We can even calculate the capacity with capacity. So and the capacity is supposed to be, is it in bytes? Creating over hundreds bytes. Okay, so it is in fact in bytes. So it's going to be width multiplied by height multiplied by 3, right? Which where 3 is the basically this thing, right? Yeah. And we need to recompile the entire thing. And yep, it didn't really become that much faster, right? But it became faster than it was. All right, so I'm happy with this thing, more or less. More or less. So yesu kawaii freaking desu. But I tried it in C and it's not that slow, because if you're using something like fwrite, right, or something like if you're using libc stuff, you're by default using buffered output, right? You're by default using the buffered output. So, but in Rust, if I just open the file, I think it's not buffered. I'm not sure if you use it. Like if you open a file with fopen, is it going to be buffered by default? The documentation doesn't really say anything, so I don't know. But we'll see. Okay. Slap some buffered output on save as ppm. There we go. I'm gonna push that right into the repo. We're gonna push that right into the repo. We're already spending like 2 hours on this kind of shit. My god. Does anyone have any questions so far? What is Rust? It's a programming language in this particular context. I'm guessing each write calls into a kernel, probably. Maybe that's the reason. I don't know. I know nothing about programming, so the only thing I know is that you know, when you buffer output, it becomes faster. Okay, all right. So what we're gonna do Yeah, first we actually need to fix this entire thing and compute pixels starting from their center. All right, compute pixels starting from their center. So how can we do that? So the most obvious thing in this particular case would be to, I guess, use floating points. Right? Maybe we could use floating points. But I'm not sure if that's a good idea. Yeah, we can try to do that. So that means in here it would be like easier to do something like this as f32. So it's a very dumb way of doing that. I do realize that, but I don't know how to do that in general. So I'm trying to discover the way you're supposed to do that, right? That's how I usually work, right? I'm implementing a very dumb solution, dumb and obvious solution, and then I'm trying to make it better. So that's how it works. So if you didn't know that you're not supposed to write ideal and perfect code first try, well, now you know, and now you became a better programmer. Congratulations. So yeah, here we have a center. Center starts from the center of the pixel, depending on whether it's even or odd. So in this case it doesn't. Oh, it's actually pretty cool. So yeah, it makes it even better because you can have like between the pixels. Yeah, that's actually pretty cool. All right, and that's pretty pogue. So, and in here we're just iterating through the pixels, and we're gonna be doing oh my god, okay, Emacs, what the fuck is wrong with me? I just want to select this entire thing, F32, and in here, what we're going to be doing is just multiply by 0.5, right? So this is going to be that. Not really, so we don't have to multiply it, because X and Y points at the left top corner of the pixel. So to get the center of the pixel, we have to actually add this entire thing like that. Not bad at all. So we added half of this thing, and then we did the comparison, and everything seems to be okie dokie a karaoke. All right, let's try to compile the entire thing and see if it's gonna compile and even work. Okay, so it produced something, and let me now do the feh. And it, oh, on a solid thing, it even got rid of these things. Oh shit, it actually looks better, I think. It has like less artifacts now. Okay, let's take a look at the small resolution. So the small resolution was 16 by 16, right? So let's take a look at 16 by 16. And if I should not actually close. I have a weird habit of closing this entire thing. Look at how symmetrical this mother flipper is. Look at that. Look at how symmetrical it is. It's beautiful. It's absolutely beautiful. I love that. So we can probably even go, you know, smaller, like 8 by 8, and I think it's still gonna be symmetrical. Right, so yep. So that was actually a good idea. So yeah, the idea of using like a center of the pixel, like it works beautifully. Huh, that's very cool. I really like that. Okay, so, and all of that is very much symmetrical. All of that is very much symmetrical. Cool. So let's do a committee. So, and the next question, can we do this center of pixel computations in integers? So that's a good question. Can we do that shit in integers? I think we can, right? So, because we always sort of take, here we have like a half of a pixel, and here we add half of a pixel. You know what I'm talking about? Right. So we always sort of like need like twice as high a resolution to do these kind of things. So we can try to achieve similar things if we keep coordinates in a twice as high resolution as it is. So we can go between the pixels. So we can have sub-pixel computation. So this is basically, yeah, it's a sub-pixel graphics, isn't it? Isn't it sub-pixel graphic? I think it is, right? We're doing sub-pixel shit. And since we always need half of a pixel we don't really need floating point for like twice as big a resolution. We can just make it twice as big and just do computations as twice as big resolution. Does it make sense? So in that way, we can get rid of the floating point and maybe potentially make it faster. I know nothing about floating point performance versus integer computation performance, but I heard that floating point is slower, I think. And it even makes sense given the representations of the numbers. The representations of the integers and operations that you do on those representations are really straightforward, very simple. So you have a very simple circuitry to add things, subtract things, and so on and so forth. Floating point have like a, 3 sections in their representation, and there's a lot of different Corey cases. There's rounding, there's all sorts of logic and stuff like that. People like wrote huge books on describing how IEEE 754 floating point works, right? So I would imagine that to work with IEEE 754 floating points, you need a lot of circuitry. So I think it would make sense they would be slow. But again, I know nothing about this kind of stuff. I'm not a very good programmer, but it kind of makes sense for floating points to be slower than integers, given the way they work, right? The representation and what kind of operations you need to do on them. Does it make sense? I think. So, yeah. And if you can avoid that, maybe it's gonna be faster, but it's kind of difficult to evaluate that without any proper profiling or any proper measurement. Maybe we need to introduce some sort of a measurement in here, but maybe we're already wasting time. We're already streaming for like 2 hours. So, yeah. So, okay. Fix the image of centering in here. I'm gonna push that right into the repo. So many questions. What do you mean? Don't see any questions. Is that what you mean? I don't understand. I'm sorry. All right. So how can we get rid of all of that? So we're gonna do it like this. So center. So essentially what we want to do, right, we want to do the computations, the coordinate computations in a twice as big resolution. So the first thing we'll have to do, we'll have to multiply this thing by 2. And then we need to find the center in this high resolution space. You see where we're going with that? You see where we're going with that? We multiply by 2 to make the resolution bigger, twice as bigger, and now we're trying to find the center in that resolution. So to find the center, we have to divide it by 2. I'm not gonna remove that, right? So the compiler is gonna remove that computation anyway, but I wanna keep it sort of to indicate, yeah, we're increasing resolution, and this is the center within the higher resolution. So, and the center within the higher resolution is equal width and height in a smaller resolution. Does it make sense? Right, so that's basically what it is. Now, so in a radius, we can keep radius also in a higher resolution, right? So this is going to be higher resolution. Yeah, it's kind of a self-documenting code. So now we're iterating y and x, but we're iterating y and x in a smaller resolution, right? We're iterating it in a smaller resolution, so that means here we need to multiply this thing by 2 to go to a higher resolution and then add half of the pixel, and in our case half of the pixel is going to be 1. And then we compare this formula, and if it's like close enough, we return foreground or background pixel, and I think that is actually it, believe it or not. That's how you convert the floating point computations from like for off-centering to integer ones. I think it makes sense. So if I try to recompile the entire thing, okay, so it panicked attempt to subtract with integer over. I see. So at some point it's gonna, okay, it's gonna underflow. It's gonna underflow this entire thing. So yet again, we have to do these computations in integers, unfortunately. Okay, so we can probably do that. Yet again, I can do as I32, as I32, and this one is going to be as I32. So, and in here we'll have to do this kind of stuff as I32. There we go. So, boom. It's saved solid, and if I try to take a look at that, everything looks pretty straightforward, not gonna lie. So now, if I make the resolution smaller, right, if I make the resolution smaller, something like 16, all right, and if I take a look at this entire thing one more time, it's perfect, and it doesn't use floating point stuff, so we're doing sub-pixel computations without a floating point stuff. So why as 32 the compiler can't infer it? What? In which place? First of all, we did as I32 in 5 places. 5 places, which one do you mean? So in this particular case, it cannot infer that it is I32 because width is usize. And you may say, okay, let's actually make the width I32. But that automatically tells the user of this function, oh, I can stick a negative number in here. No, you cannot. You cannot stick a negative number in there. It has to be positive. So making it usize on the interface tells the user, no, you cannot set width negative. You cannot set it negative. And we're converting it to I32 to signed one for internal computations. Only we are allowed to do the signed computations on these things. The user of this function not allowed. Like you only provide 0 or higher. So that's basically the point, right? So this is all of that needed is for the interface, and internally we convert it to I32 to do the rest of the stuff. Right, we're not allowing the user to control these kind of things because they're very sensitive, they're very important. Right? Otherwise, we're going to underflow or overflow and stuff like that. But to be fair, I32 is a smaller type than usize, so there's still some problems in here that could potentially arise if usize is too big and doesn't fit into I32, and I32 may become negative because of that. There is a lot of problems in here, but again, Rust will probably throw a runtime exception for these kind of things. I don't know, doesn't matter. Okay, so everything seems to be all right, and we can probably simplify that even further, as already mentioned. Right, we can probably simplify it even further because this kind of computation is useless, right? And we already know why we're doing all that, so we don't need these kind of things. Right, so I'm going to remove that. So now center is that. And do I need anything else? Let's actually make the code even more cryptic than it was. We can remove these things, and boom, this one is -1. So now whoever is going to read this code, they will not understand why the fuck we even doing all that. We're gonna even remove the to do, right? So they will look at this code and will think, why the fuck do you do that? Why is what? Double -1? But then they will see a perfect round circle and they will go, oh, this person must be like a 5-head or something. Holy fucking shit, how did they know that they have to do all of these things to make a perfect circle? But we know. We actually went through all of the logical steps and we erased those logical steps, making the code more cryptic. You see? So we started with a very dumb 3-head solution that uses floats. Then we transitioned to integer solutions with a twice as high resolution, and then we compressed all of these things, and now it looks like we came up with this solution first try, and that's how you achieve your job security. You write code like that and nobody can basically fire you because nobody understands this shit. So this is how it works. All right. Yeah, that's pretty cool. And I want this thing to be also usize because we're using them for accessing the pixels and whatnot. I wonder if the compiler can infer that with this kind of expression and with these ranges, I'll never gonna go out of boundary of pixels, so it will never generate boundary checking for this specific code. I wonder if the Rust compiler is smart enough to do this kind of thing. Because it may know the size of the pixels, it can derive it from how we call this function, right? Maybe, I don't know. So because all of the information that is necessary for the compiler to do that is available here, because here it is, all of that is the compile time, we don't get anything at runtime, so maybe it would be able to infer that. Plus all of these functions are internal, so it will probably, it doesn't have to export them, so it can even inline some of the things and eliminate some things. So maybe, I don't know, I know nothing about compilers, so, and how they work. All right, that's pretty cool. So I'm super happy with that. Okay. So do sub-pixel computations in fill solid circle in. Okay. Do integer sub-pixel computations in fill solid circle, and I'm going to push that right into the repo. Okay, so the final boss of today's stream is drawing the hollow circle using midpoint visualization. Let's take a look at this entire thing. Oh yeah, I'm going to give it a star, of course. I really like it now. Okay, so I really like this visualization because it basically explains everything that you need to do. That's pretty cool. So the idea of this thing is that you only need one arc in here, right? You only need one arc, and then you can basically invert and flip pixels around to actually like fill the rest of the arcs. As soon as you know this thing, you can mirror the pixels around the center and fill the rest of these things. I guess that's the idea. Yeah, so basically you can focus on rendering only one arc, this one. So, and you start with x equals 0 and with y equal to the radius. Makes sense. Another interesting that I can thing I see is that x is always increasing, right? X is always increasing, but y is decreasing sometimes. Yeah. So I suppose y should decrease to maintain sort of this formula to be true, if I understand correctly, right? So yeah, you basically decrement y when this thing drops maybe below r, or maybe, yeah, I think this thing should grow. Yeah. If you decrement x but never decrement y, the entire sum will grow, and as soon as it grows like over r, you have to decrement y, bringing it back into the circle. Yeah. Oh, that's actually pretty cool. I think I understand that now. Right, so if you increment x, you go out of the circle, and if you go too much, you sort of bring it back, and so on and so forth. All right. I think that makes sense. Does it make sense? We can try to implement that now. What do you think? I suppose we keep doing that at some particular point. When do we stop, though? When do we stop? I suppose we can stop when x becomes bigger than y. Yeah, that makes sense. Yeah, so you basically stop at this particular corner, and in this corner, basically x becomes bigger than y, and you don't have to generate anything else. Okay, looks good to me. Let's go ahead and do that. All right. So we're gonna start with what? This is underscore. Let's remove all of these useless underscores. Okay. We're gonna have x, which initially, as we can see, so we start from here, it starts from 0, right? Then we're gonna have y, which starts from the radius, right? So here's the radius. And we keep doing all of that while x is less than y. Or maybe it could be also equal. Yeah, let's actually allow it to also be equal, just in case, I don't know. Yeah, so we effectively just increment x by 1, right? We just increment x by 1. And periodically, right, we need to check some sort of a condition, We'll also have to increment y by 1 as well. You see? So, but the question is, what is going to be that condition? That's a very, very good question. We need to understand what that condition is going to be. I have an idea. We can try to maybe log this entire thing. So we're going to have x, and then we're going to have y. And I want to check what x, y plus, actually xx, so it's like square x, then y equal to, compared to the radius, to the square of the radius, right? So this is going to be x, and this is going to be y, this is going to be x. Might as well copy paste this entire thing, might as well copy paste it. And then we need to something like RR, so I might as well actually put R in here, just in case. Maybe I'm going to put it in here, and then I can say that this is the start point of y. Okay, so... wait. Oh, this is perfect. Look. Yeah, perfect! Who needs string interpolation in Rust if you can just do shit like that? So... oh, this is 5 hit. Holy shit. I wish I could just put these parameters in here, you know, but I cannot because, you know, Rust people don't think it's important. I rather prefer like a TypeScript, you know, string interpolation, so we can like see in line what kind of expressions you put in there. I don't like the idea of formatting strings and list of the arguments separately. It is very difficult for me personally to read this kind of stuff. Right, so I think separation of format string and the list of the arguments is kind of meh. I think they have to be merged together. I rather prefer like a Pascal style of things where you do write ln x equal x, then y equal y, because at least the formatting string and the arguments are in the same place. It's a little bit like additional stuff, the noisy stuff in here, but at least they're in the same place and you can read them left to right. Right, with the separation of formatting and the arguments, you first have to read the formatting string, remember what was the formatting, and then look at the arguments and go constantly back, associate arguments with the formatting string, constantly like jumping back and forth. It's like forcing the developers to define all of their variables at the beginning of the function, and then have a huge function that uses this variable. So it constantly forces you to jump back and forth. Right, so here we define all of them at the beginning because they're used all the time, like immediately here. So we define them here and we instantly use all of them in here. So that's why here it makes sense. But yeah, it's kind of an equivalent of defining all of the variables at the beginning of the function always, right? So, and I personally don't like it, but it's just me, right? So readability is a subjective thing. Some people can hold a lot of things in their head, and thus for them it is totally fine. So, and they don't understand what kind of problems do I have. But I'm stupid. I forget things very easily. So for me, it's kind of hard. Yeah. And Pascal style, even Pascal style, just find it easier to read for myself. But because I'm dumb, right? So smarter people don't find this as a problem at all. Because again, they can hold a lot of things in their head. No appreciation for dumb people like me. No appreciation for dumb people like me. Anyways, so we have a draw hollow circle, and let's see if we can have anything. Okay, so here's the log of what's going on. Okay, at the beginning, the value of x and y is 0, 8. So, and the formula x squared plus y squared is equal to 64. It's exactly equal to the square root of the radius. As soon as we go further in x, you see we don't touch y. Y still stays the same. As soon as we increase x, this sum keeps growing over the radius. It keeps growing over the radius. It keeps growing over the radius, and here is the thing. So we can actually check that if x y plus actually x y y greater than r, we can go ahead and decrement y. Right. So basically, we keep increasing x. And if we go over the radius, we decrement y, trying to bring the circle back into, trying to bring the pointer, the pen, because this is the position of the pen, right? We're trying to bring the pointer of the pen back into the circle, sort of maintaining this thingy. Does it make sense? I think that's how you can do that essentially. So let's take a look at the log. Okay, so that looks a little bit interesting. Look at that. So x growing, y growing like slightly. So the sum dropped below r, but then we try to, it doesn't really go exactly at 64, but it tries to stay as close to it as possible. You know what I'm talking about? Right, it tries, at least it tries to maintain there, but as soon as we increase x, it just tries to go to the right and become bigger. And I suppose here are the coordinates of the shell of the the octal thingy of the circle, and we can try to render this thing. All right, looks good to me so far, I'd say, more or less. So the next thing we want to do is essentially just put a pixel in there, right? So let's just go ahead and draw a pixel in there. To be fair, it would be easier right now to fill everything with a background, right? And just forget about it. So we'll fill everything with the background, and we're going to be placing foregrounds into the pixels. Right, but X and Y is actually not the place where we want to place them. We need the center, right? So let's actually compute something like CX width divided by 2. And maybe here we also want to have some sort of a sub-pixel computations at some point, we'll see. We already know how to do sub-pixel computations. But right now I'm not going to care about sub-pixel stuff. Gia, what's up? What's up? What's up? What's up? What's up? Look what we're doing. We're doing actually a lot of cool stuff. We generated checker patterns. I'm not sure if it's possible to see them. Let me actually open all of the ppm files. Everything is so small. God damn. We can't see shit. But yeah, so I'm gonna show everything as we finish this algorithm. We need to finish the algorithm first. Okay, so I need to do pixels y multiplied by width plus x, but this is not the place where we're gonna do all of that, right? So maybe yet again I want to do all of that in this thing. This one is also I32, and that makes these things also I32. Oh boy. Alright, so after that we need to take x and add cx, and that brings us to the position where we want to render all of that, right? So we want to put it like this. Y, maybe I'm going to call it p, x and py, so for position. So it's going to be y, y. But here's an interesting thing. This kind of stuff may be negative or way over the boundaries of the thing that we're trying to draw. That's kind of the problem. So we need to check. So what are the boundaries of this thing? So it's going to be width, right, as I32. Might as well just do something like this, W. W is going to be width as I32, and H is going to be height as I32. This one is going to be W, this is going to be H. Right, and because of that we don't need that stuff to be that. Okay, so we're accepting width, height and radius and converting everything to I32 right away, right? So we can do all of the computations in a sine thingy. So here is the center and here's the initial things. Then we calculate the position and we check if that specific thing contains px. I think you also have to put a reference in here if I remember correctly. I remember being burned by that. And then if it contains y, only then we'll have to do a very interesting thing where we use py, but we have to convert it to u size, and px, but we have to convert it to u size. Right, holy shit. Okay, so and then we can place foreground in here. I think I took into account everything. I think I did. So yeah. I hope I did. So my neighbors are doing something weird outside. So okay, I'm gonna try to ignore them. Anyway, so let's go ahead and just try to run. And it didn't even crash. Look at that, it didn't even crash. So okay, here's the hollow. And we can see a couple of pixels. So if I set so where is the hollow? If I set the background to be a little bit brighter, right? So what we can set the background to be? Let's make it white. I don't know, maybe we can make it green so we can see a little bit better. Okay, so and all right, so we actually computed like 1/8 of the circle. That's what we did. It's 1/8 of the circle. To be fair, maybe the radius has to be a little bit smaller. It's kind of hard to tell. So let's actually make a bigger resolution, 512. Right, so it's going to be 512, and for the radius, we're actually using half of the height, but I might as well actually put half of the width. Maybe I need to introduce the radius as well for those things. I don't know, haven't decided yet. All right, so what do we have in here? And oh shit, look at that legitness. So this is like 1/8 of the circle. It's 1/8 of the circle. So let's put the background thingy in here. All right. Oh shit. Okay. So I wanted to show you what the fuck we're doing. Like we were generating different patterns in here, like a checker pattern, then stripes, then solid circles and stuff like that. And we're trying to now generate a hollow circle. Right. So we generated 1/8 of this thing. Right. So it's basically 1/8. So now we need to generate the rest of these things, I suppose. Yeah, need to do that. But we will need to actually check a lot of additional shite. But maybe it's not that even important. If we know that px and py are within these limitations, that shouldn't be the problem at all. That shouldn't be the problem at all. As long as width and height are the same, so it shouldn't be a problem, I think. Let's actually do something like dx as going to be px as usize, and dy as going to be py, and we're going to have an assert in here saying that width has to be equal to height. So that's basically what we're assuming here. So it's going to be dy, and then dx. So we can easily compute another 1/8 of the circle by simply swapping the coordinates around. That's it. So that's amazing, actually. So that's the beauty of this entire thing. You can compute another 1/8 of the circle by just swapping them around. Easy. So only 6/8 to go. Right, only 6/8 to go. So what's going to be the next one? Okay, so we can sort of mirror dy around. How can we mirror dy around? We can subtract it from height. By subtracting it from height, we're basically mirroring it around. Right, so there we go. So I should, yeah, there we go. So another 8. And again, you can quite easily get another 8 for free if you swap the coordinates around, like this. There we go. So basically, filling the rest of the circle is basically flipping coordinates in mirroring, flipping and mirroring, and then you can have 8/8 of the circle. All right, so we have another one. So, all right, so what's going to be the next thing? We mirrored y. Let's now mirror x. So this is going to be width minus dx, right? We get another one. Okay, we get another one. And again, we can actually swap the coordinates around. Who said we cannot do that? dy minus width dx. Another one. So only 2 to go. So basically we mirrored height, basically y and x separately. Let's actually mirror them simultaneously, right? Why not mirror them simultaneously? So this is going to be height minus dy and width minus dx. There we go. And there's only 1 to go. And this is basically by swapping these coordinates around. Easy. Yep. Well, there's something missing in here. Oh, I think I know what is missing in here. Yeah, I think I know. So the circle is too big. It doesn't fit fully into the stuff. So what if we make it like a third of the width? Let's actually make it a third of the width. Okay, so, but now it is suffering from the same kind of problem of having this like thing, right? So it has this thing around, but this is probably because we don't have a subpixel evaluation. So maybe this is something that we can apply as well. And it's actually a very simple algorithm if you look at it, right? So yeah, you basically iterate, like increment x and decrement y only this sum goes over r. And then you just clone the 1/8 of the circle, you know, 8 times, like mirroring and flipping things around, right? So that's basically the entire algorithm as well. Okay, so we need to do the twice of the computations. Okay, so this is the double radius in here, and this entire thing seems to be working. I'm thinking that I'm gonna try the same like steps, right? So same logical steps. Because it's kind of difficult for me to jump into this kind of stuff immediately, right? It's kind of difficult to jump to this kind of stuff immediately, so that's why we're going to be doing that in floats. F32, right? So because of that, the center is going to be divided by 2, which is fine. So this one is going to be something like this. This is going to be something like this. So, and now we increment this stuff by 1. Man, it actually makes it kind of difficult to... I guess that's fine. So in here... Yeah. So is it possible to have like floating point ranges in... maybe it doesn't matter because you basically compare the ends, right? So it just really doesn't matter. And then you're just doing it like this. Right, so the center is that, but the actual position, right, it's plus cx, plus cx, but you also want to add, you want to start from the half. Oh shit, okay. That makes sense. So x, well, x is technically at the 0, right? But the radius y has to be minus 0.5, something like this. So you subtract like half of a pixel, right? You subtract half of a pixel, and yeah, then you just iterate by 1 pixel. So we only always stay like within the center of the pixel. All right, so will that work and produce anything reasonable? And it freaking did. Okay, so we applied subpixel stuff and we got rid of all of that bullshit, and everything looks okay. Right. That's actually pretty cool. So essentially, for those who's curious, what subpixel bullshit I'm talking about, if you have, right, coordinates of the pixels, right, so we have 2 coordinates of pixels and you compute the distance between them, what you're doing in reality, you're computing the distance between the left top corner of the pixel and of 1 pixel and left top corner of the another pixel. So you're actually computing this kind of thing. So your entire image, because of that, is sort of offset left top. Right, so it's just sort of offset left top. So we're doing computation starting from the center of the pixel, and because of that, it just like looks better, if you know what I'm talking about. Right, so I can probably show you an example, right? So if we don't do this kind of thing, I guess the easiest way to actually see the example is just don't do this -half, right? Just don't do this -half, and I think it will yeah, there we go. So you will see these kind of things sticking out, which are kind of weird, and the overall shape has a lot of artifacts. But if we do sort of a sub-pixel evaluation starting from the centers of the pixels, right, so starting from the centers of the pixels, we're don't have any of that stuff anymore. But again, we're doing all of that in floating points, which is kind of finicky and not very fast. One of the things we did with the fill solid circle, right, with the fill solid circle, is that we transitioned from the floating point computations to the integer computations. Right, and this is probably something that we want to do in here. Okay, so that's kind of interesting. How can we achieve that? So yeah, my brain stops working actually. My brain stops working. Hey, at school I did a similar task. I drew a circle in Java. Only I used sine wave so that no pixels were visible on the edges of the circle. All the values of the sine wave lie in a range from 0 to 1. I just multiplied the value by thousands or more, and so that close the circle, the resulting quarter of a circle was duplicated and inverted 4 times. Could you quickly repeat your implementation? Sure. The implementation I used is actually visualized in here. Right. So basically, you can notice on this visualization that you need to only iterate one quarter. You already know that, right? So, and you can see that x is always growing. X is always growing. So you can have iteration that always does x plus 1. But y is decreasing only occasionally. The question you need to ask, when do you increment y? Well, I suppose you increment y when your x and y point goes outside of the circle. When does it go outside of the circle? Well, when the formula, the famous formula, basically x, oh boy, x squared plus y squared becomes greater than r, right? If this sum becomes greater than the radius, that means your point went outside of the circle and you want to decrement y to bring it back into the circle. And that's the entire implementation. Look, while x is less than or equal than y, we're incrementing x, and if this thing goes outside of the circle, we decrement y. And then we take these points, we check that it's within the range, and we put in it corresponding places, mirroring, and so on and so forth. And that's it, that's the whole implementation. Really. So you need to understand one simple thing, all right? So x is incrementing always, y is decrementing occasionally, but it's incrementing because you want to keep this the point within the circle. Very straightforward. So yep, I'm not sure if it produces an accurate, you know, circle representation, but it's good enough. It looks fine. Does it look okay to you? We can take a look at this thing in lower resolutions. For instance, 32 pixels by 32, right? So where is the hollow? Yeah, there we go. So we have a lower resolution here. On a lower resolution, it also looks fine. So what about even lower resolution? 16 by 16. Yep. So this is even lower. That's very lovely. I really like that. So generated with such a simple algorithm that doesn't require sine, cosine, or any of this stuff, it works fine. So yep, and you can actually increment to like 1000, like 1k pixels. So this is basically 1000 by 1000. Yes. Kawaii freaking this one. We also have this kind of stuff. This is the full circle. We also generated with a different algorithm, but it also looking mighty fine. You're welcome. You're welcome. So yeah. So let me see. I want to get rid of the floating point computations in here, but I'm too tired. Right. So maybe I'm gonna put it to do in here, saying something like, I don't know. I think I want to finish that. Right. So I think I want to finish that. Again. So we got a donation. What is that? What is that? What's going on? Just a second. I need to update my circle. I was banned for asking why you're making a circle. I'm very intrigued and I just want to know why you're making a circle, please. Okay, so I would recommend you to watch the stream from the beginning, because we discussed the reason why we're doing all of that at the beginning of the stream. So you just basically missed the beginning of the stream. If you don't like to watch VODs on Twitch, this VOD is going to be available on a Tsoding Daily channel. So basically, go to this channel, just a second, youtube.com Tsoding Daily. Right. So, and tomorrow, the recording of the stream is going to be available there. Right. And you will be able to watch and like see why I'm doing all of that. So the new video, no, it's not the new video. Okay, so the new video is going to be available in actually 3 minutes. That means I have to actually stop my stream soon. So the reason why I'm doing all of that is because I was just looking through my old projects, and one of my old projects that I developed, I think 5 years ago, right, was Midpoint circle visualization. Right, and this was just a test project to learn about Midpoint circle visualization. And I quickly implemented it just to see. This looks actually quite cool. I want to implement that. That I implemented just to see how to do that, and then I used it in my other project. Right. So it was just a test. But I looked at this test. And it was kind of crappy. And 5 years ago, I didn't have that much of the experience in programming in general, and I thought, well, I have more experience now. Can I do better tests than this? And that's basically what I'm doing right now. So I'm just like looking at this algorithm from the point of view of 5 more years in programming. Right. So I implemented that algorithm 5 years ago, having less experience, and now I have 5 more years of experience, and I just see if it makes any difference. And to be fair, it does make any like a lot of difference, because I actually understand what the fuck I'm doing, because I remember at the time I didn't understand what the fuck I was doing, and that's pretty cool. So that's basically it. Thank you for $3. Thank you so much. So you were not banned, by the way. You were timed out for 2 hours, so it will be automatically unbanned in 2 hours. So that's basically it. Thank you so much for the donation. All right. So thank you. I can die happy. No, please don't die. Dying is against TOS. So if you die, Twitch will ban you. Dying is against US. But thank you so much for $3 more. Really appreciate it. But don't die, it's against US. All right, so what do we have in here? I guess I'm gonna leave it as a homework. Right, I already showed how you can convert like floating point sub-pixel computations in a solid circle, and I'm gonna leave this as a homework for you, dear viewer. How would you do that for this one? Right, so I don't have to do that myself. Anyway, so we need to do sub-integer sub-pixel computations in draw hollow circle. All right, so okay, I'm not sure if I actually implemented the midpoint circle algorithm. The only reference I used for this algorithm in 2021 was this visualization. I'm not sure if my interpretation of this visualization was correct. Please let me know if my interpretation of this visualization was not correct, and let me know, maybe in an issue, maybe somewhere in the comments or something like that. So yeah, but this is just my interpretation. And if I need to generate this sort of like a hollow circle at some point in the future, I'm definitely going to be using this algorithm, because it's really to understand, it's really easy to remember, and yeah, it's fine, I guess. It's actually pretty cool. I didn't expect that generating this circle would be that freaking easy. You just try to keep the pen within this, you know, this range, and it's fine. Okay, so what we're gonna have in here. So do I want to keep the resolution that huge? Maybe I do. We'll see, we'll see. So let me regenerate everything, and let's take a look at this stuff. So here is basically all of the patterns we generated today. Yes. Implement draw hollow circle. There we go. And let's push that right into the repo. Do you think this implementation is faster than using sine and cosine? My guess is that way is faster. Yeah, I think it's faster than sine and cosine because computing sine and cosine is actually pretty expensive operation. Believe it or not. So there is, as far as I know, there is no all of one operation to compute sine x in the arbitrary resolution. So that's kind of the problem. You can't compute sine x in O of 1 with arbitrary resolution at all. So you have to use the... How do you compute sines actually? Computing sine. Taylor series? I think you're using Taylor series. Taylor series sine. Yeah. Yeah, and Taylor series is like... Yeah, you pick a resolution and you keep computing until you like meet a certain resolution, right? So you can have tricks like lookup table. You can pre-calculate sine x, but if you have a lookup table, you have a fixed resolution, right? You have O of 1 with a fixed resolution, right? But you can't have O of 1 with arbitrary resolution, right? So, well, technically you can basically have a lookup table for sine with a fixed resolution, but then you need to check the resolution that you want. But again, then you cannot scale and like upscale and downscale your image that easily, because as soon as you scale too much, the resolution of your sine lookup table is not going to be very good. And what do you do now? Recompute it again, I guess, with a bigger resolution. But the bigger resolution, the bigger memory you consume, right? So because you need to store all of these like data points in sine. So yeah, there's a lot of problems with using sine to draw a circle. It's better to avoid that, in my opinion, if you know what I'm talking about. Just use silicon for hardware lookup. Easy, yeah. How does the like hardware accelerated sine and cosine work? Do they like literally do Taylor series on like on the hardware? Probably. I don't know if there's any other ways. No idea. Yeah, also have no idea. Anyway, I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you on the next stream. On the next stream, we're going to be doing something else, I suppose. So today's stream was actually very freaking good. I really liked that. That was super fun. Did I push the changes? Okay, so you can find this thing in here. Right, you can find the implementation in here. The new implementation is going to be available in this folder. It's just a single self-contained Rust file that generates a sequence of ppm images. You have the whole visualization framework in here. You can change the resolution, foreground and background colors, and you can look all of the algorithms that generate different patterns and stuff like that. And all of that doesn't require any frameworks, any libraries or anything, so should be fine, I guess. As long as you have something to view ppm. I'm not sure if there's anything on Windows that can view ppm, if you know what I mean. So maybe Chromium can view ppm. I don't think so. It cannot view ppm, unfortunately. But you can find. I think ImageMagick is capable of converting the ppm files to any like PNG files or whatnot. So yeah. Anyway, that's it for today. Thanks everyone for watching. I see you all next time, and I gotta go. Hope it was interesting to watch. Right, love you.